As we move into chapter 4 now, we're going to shift gears completely and talk about graphing of the 6 basic trig functions. And if you remember when you first learned graphing, I mean, what method did you use? If you had a function that you didn't know what the graph looked like, what did you do? You made a table, you plotted some points, and you tried to see the pattern. So that's what we're going to do here in terms of the sine and cosine graphs in this section. So we're interested in sketching the graph of y is sine x, just the basic parent. Remember in the college algebra you called this the parent function, like y equals x squared, y equals x cubed. You learned the basic parent functions first, then you learned about modifications of those. We're going to do the exact same thing here. So I'm making a table here of x values. So you take sine of an angle, so x are angles. Now in this chapter we're doing all the angles in radian measures, so hopefully you have a decent feeling for those now after doing chapter 3. And I want you to notice I've chosen quadrantal angles, and I think I mentioned in chapter 3, how do you recognize an angle in radian measure in simplified form? How do you recognize that it's a quadrantal angle? Either the denominator is 2 or the denominator is 1, right, like pi over 1. Right, so if you have an angle in radian measure in simplified form, and you have a pi in it obviously, and you have a fraction that simplifies, and you have a 2 in the denominator or a 1, that means it's a quadrantal angle. Do you remember in the previous section how I told you how do you recognize an angle in radian measure that has a reference angle that's one of our special triangles, the 30, the 60, or the 45? Remember then that when simplified form you have a pi and the denominator is either a 3, a 6, or a 4. So 7 pi over 4 I know has a reference angle of pi over 4 and will be a special triangle. Okay. So all of our angles in radian measure, and I've chosen the quadrantals on purpose because we know how to find trig function values of those very easily. I'm going to use the unit circle. So pick the point 1 unit away, that's the point 1, 0, 0, 1, minus 1, 0, 0, minus 1. Okay. Now if you really want a good picture of any graph, you shouldn't pick things like I did here where everything is a quadrantal, or when you're graphing y equals x cubed, you don't want to just pick minus 1, 0, and 1 because you're going to be inclined to connect things the wrong way. So I'm not really being smart about this, but I know what the graph looks like, so I know I'm going to be okay. Okay, so remember when you use the unit circle for angles, for any angle, but in particular quadrantals, the x value gives you the cosine of the angle, and the y value gives you the sine. So I'm doing sine of x. So I'm going to be picking off the y values here to get my y value, my sine. So where is negative 3 pi over 2 radians? That's negative 1.5 pi. So again, negative angles we rotate clockwise, so that would be negative pi and another minus half pi. So negative 3 pi over 2 is here, and what's the sine of that angle? 1, the y value. Okay. Now where's negative pi radians? Negative pi radians is here. And what's the sine of negative pi? 0. Negative pi over 2 is this angle, and what's the sine? Negative 1. And notice I picked all quadrantals, and I'm picking them in order. I'm not skipping anything. Where's 0 radians? 0 radians is here, and sine is 0. Pi over 2 radians is here, and sine is 1. Again, I'm picking off the y values. Pi radians is here, sine of pi is 0. And 3 pi over 2, that's 1.5 pi in the positive direction, puts me here, and sine is negative 1. Okay, so there's my chart. Again, I could have kept going. Now, notice the pattern. I started at negative 3 pi over 2, which was here. Notice I'm just going around this way. 1, 0, minus 1, 0, 1, 0, minus 1. That's what I did. Okay, now let's plot these points. So my y values, again, this isn't a complete picture, but from what I have, it looks like the values are only going from minus 1 to 1. I need to label. So here's 0 radians. Every pi over 2, so 1 pi over 2, 2 pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, which is pi. 1 pi over 2, 2 pi over 2, another pi over 2 would be 3 pi over 2. And likewise, these are the negative values. Okay, so now I'm just plotting like we normally plot. So minus 3 pi over 2, 1. Negative pi 0, negative pi over 2, negative 1. 0, 0 is the origin. Pi over 2, 1. Pi, 0. And 3 pi over 2, negative 1. It's a little lopsided here. Okay, so we have some points here. And again, it really would be helpful if I added more values in here to see what happens in between. Because here you might be inclined to just connect these with little line segments. That's not what happens. So I'm just trying to get you to see that my graph here is going to make sense from what we did. So if I did add some things in between, you'll see there's curvature here. They're not line segments. So in fact, the graph does something like this. There's curvature here. Now, when I write the arrows on the end, I'm not trying to say that this goes up forever or this goes down forever. Arrow means the graph continues. So this is the graph of the basic graph of sine x. Now, it should not surprise you that my graph is trapped between -1 and 1. What we learn in section 1.4, I believe, about the range of sine. Sine of x is always between plus or minus 1. Remember that. So again, that's how I know the arrow doesn't mean go up forever, because I know sine is always less than or equal to 1. So I know it's going to come up to 1 and turn back around again. So this pattern continues. So there's your graph of sine x. Okay. Now, what I do, once we do this, I plotted the points to get the basic sine graph. After this, I'm not going to plot points ever again, okay? I mean, once you learned that the graph of y equals x squared was just your basic parabola passing through the origin, you didn't ever plot points again. You just knew that was the basic shape. So here's what you need to, how to reconstruct the sine graph without doing, all of this mess, right? Remember, on the basic sine graph, y equals sine x, something important happens every pi over 2. Important meaning a high, a low, a maximum, a minimum, or a 0, okay? I'll just say a low, a middle, high, okay? So every pi over 2, something important happens. The sine graph does what on the y-axis? Crosses at 0, 0. You just need to remember that. So the sine graph crosses the y-axis at the origin, and as you head to the right from there, the graph goes up. The graph increases. So if you can just remember those things, you can reconstruct the graph, right? I mean, if you just said, every pi over 2 minus pi over 2, 0, pi over 2, pi. I know we're running from -1 to 1. The sine graph crosses the y-axis at the origin, and as I head to the right, I go up. So that's a middle, that's a high, that's a middle. Middle, high, middle, low, middle. Okay? So you don't have to reconstruct this every time you do the sine graph. Okay, now it's the I'm getting ahead of myself. I'm skipping down to the definition. We'll go back and do cosine in a minute. The graphs of sine and cosine turn out to be periodic. This isn't a real full-fledged definition. I just wrote it in words you'd understand, meaning the graph has a repeating pattern. So there certainly is a repeating pattern here. Okay, let me extend this just to make a point. Okay, so the graph continues in both directions. Now, do you agree? Let me do this. From here to here, from this low point to this low point, wherever that is. Okay. If I pick this graph from my blue line to my blue line here, if I picked the graph up and moved it and placed it down here, wouldn't that continue? Wouldn't that fit the pattern? Again, from here to here, if I picked that piece of the graph up and moved it over and put it back down, it would fit. It would continue the pattern, right? So, and you could place it again and again and again, and you would get the whole graph eventually. And same thing down here, right? Pick this up, move it over here and place it. So if I just took this piece and repeated it over and over and over again, I would get the entire graph, okay? So the period of a graph is the interval of the shortest interval of x values for which the graph repeats. So this certainly satisfies the condition that if I pick it up and move it, I would continue the graph. That part does repeat. Now, from here to here, would that be the period? The total distance from here to here would be 4 pi if I continued. And is that the shortest interval of x values for which the graph would repeat? And the answer is no, right? That's too big. Because I could do that same sort of procedure going from here to here, actually. I don't have to go all the way to here. I can go from here to here. Notice this low to low, pick it up, move it over, low to low, pick it up, move it over, low to low, etc. Okay. Now, could I do the same sort of thing again by making this interval even shorter? No, if I make this any shorter, I'm going to leave out part of the graph. Like if I move this line a little this way, that part of the graph I won't get. Notice this is low to low, and I get the whole cycle here. Okay, now how far is it from minus pi over 2 to 3 pi over 2? That's a total distance of 4 pi over 2, which is 2 pi. So the period of the sine graph is 2 pi. Now what does that mean? If you're at a high point and you move over 2 pi, you're at another high point. If you're at a low point and you move over 2 pi, you're at another low point. Now if you're at a 0, like here, this is a pi. If I move over 2 pi, I'm going to be here. Notice it's another 0. Now, notice if I only move over pi, I also hit a 0, but I think of these as being different zeros. This is a 0 on the way down. That's a 0 on the way up. So if you're at a 0 on the way down and you move over 2 pi, you're at another 0 on the way down. Okay, that's the way the period works. Wherever you are, and that's not just high, middle, and low. Like notice right here, this point right here, wherever that x value is, if I add 2 pi to it, I'll be there, right? So wherever that is, add 2 pi, I'm there. It's the exact same point. Okay, it's on the way up almost to the high. So I've kind of ruined my graph. I hope you didn't ruin yours, but there's the basic sine graph. All right, now let's do the same thing for cosine. I'm going to use the exact same x values here. So write your table again. And I'm going to use the quadrantals again, so I'm going to keep my little picture here. Okay, so now we're going to sketch the graph, the basic cosine graph. Now, when I'm using the unit circle again, when I take cosine of an angle, of a quadrantal angle, what value are we pulling off? Remember, the first number is cosine, x value. So sine was the y value, and then cosine is the x value. Okay, so when I take cosine of an angle, the answer is going to be the x value. Now, where's minus 3 pi over 2 again? Minus 3 pi over 2 was here. Cosine of minus 3 pi over 2 is 0. And negative pi radians is here. Cosine of negative pi is negative 1. Negative pi over 2 radians is here. Cosine is 0. 0 radians is here. No rotation at all. Cosine is 1. Pi over 2 radians is here. Cosine is 0. Pi radians is here, cosine is negative 1, and 3 pi over 2 radians is here, cosine is 0. So I did the exact same thing I did before with the sine graph, but remember sine I was pulling off the y values, now I'm pulling off x. So I went 0, minus 1, 0, 1, 0, minus 1, 0. And if I had continued with more angles, I would have just kept going round and round. Again, I'm just using quadrantals. That doesn't really give you the whole picture. But let's plot the points we have. So pi over 2, pi, 3 pi over 2, negative pi over 2, negative pi, negative 3 pi over 2. Notice again, I'm running from negative 1 to 1, which should not surprise you because we learned the range of cosine is also between minus 1 and 1. We learned that in section 1.4. Now let's plot our points. Negative 3 pi over 2, 0. Negative pi, negative 1. Negative pi over 2, 0. 0, 1. Pi over 2, 0. Pi, negative 1. And 3 pi over 2, 0. And again, if I pick more values in between the quadrantals and add them to my table, you'll see this is curvy as well. It's not line segments. And so it does something like this. So there's your basic cosine x, y equals cosine x function graph. So again, after this point, I'm not going to make tables anymore. You just have to remember what the parent function looks like. Now, just like sine x, the graph of y equals cosine x, something important happens every pi over 2, a high, middle, or low, max, min, or 0. But here, you have to remember, what does the cosine graph do, the basic cosine graph do on the y-axis? It crosses at 0, 1. Remember, sine crossed at the origin. And remember I said when you go to the right, the sine graph from there headed up. You have to remember that because from a middle you can either go up or go down. So that's why we had to do that with sine. The good news with cosine, you know cosine of 0 is 1. On the y-axis, the cosine graph crosses at 0, 1. You know that's a high because 1 is the maximum value for cosine. So you know there's a middle on either side. So once you know that's a high, you've got a middle and then lows, etc. So that's easier to remember. You don't have to worry about, are you headed up or heading down? From here, you know you're heading down in both directions. Okay, now what about the period of cosine? If I could do the exact same argument I did before and extend, right? If I went from this low to this low and picked it up and moved it, then it would all match. But that's not the smallest interval that will do that. Again, from this low point to this low point, if I pick this up and move it over, you'll continue the graph. So it's just like the sine, and you can't get any smaller than from minus pi to pi because then you leave out part of the graph. And what's that distance from minus pi to pi is 2 pi. So the period of the cosine x graph is also 2 pi. Right? So you need to remember the period of the sine graph is 2 pi. The period of the cosine graph is 2 pi. On both graphs, something important happens every pi over 2. The range is from -1 to 1. The cosine graph crosses the y-axis at 0, 1. And that's a high, so the next places are middle on either side. The sine graph crosses at 0, 0. And as you head to the right, the graph goes up. So you have a middle and then a high at pi over 2. So if you can remember those basic facts, you can reconstruct the graph. You don't have to make a table. I don't want you to make a table after this. Okay, so that's the first part, and there's a second part, a second video that'll continue on with the rest of the section.